yourself up quick.
I almost can't. I was so warm yesterday, I almost didn't bring a jacket.
That was chilly yesterday.
What was that picture of that you set up?
You cover from coffee still?
Yes, we can see you
Some of this stuff I'm just going to skip through quick. I mean, just skip, you can read it on. So that we don't run out of time. Or patience. I'm just going to skip over this.
I'll just go outside in another hour and come back up.
Yeah, because I want to get the detail today. I picked this as an example. I don't like this on. Could you hear me okay before?
Yeah.
I don't like this.
That looks just like Georgetown University right now. That looks exactly like
I picked this as an example just to show you now what is occurring. This is a Center for Interactive Research on Sustainability at the University of British Columbia, and it's touted as being the most sustainable building in North America. Now, I can't back up, but this was done by Busby, Perkins Will, were the architects, and they were the people that won the competition in Edmonton. And I just thought I'd show you the building to give you some idea of what one now goes through. It's not just about leads or so forth. It's really thinking very differently about the building itself. So because it was a building for research on sustainability, they wanted to be exemplary. So it's got 2 4-story wings, a central atrium, and it's got a lot of different uses in it. And it's got a cafe, and it's got active building management. It's got all the bells and whistles. One of the things that's interesting, and we're getting into this whole debate now, is building high-rise with wood. Now, because of the industry in British Columbia, they've had a lot of influence on their building code, and they're going up to 7 floors now in wood. And they're going into a heavy post and beam. We were in the midst of changing our building code to allow 5 floors in wood, and then we ran into a big problem about 5 weeks ago. A project that was in construction, student residences, during construction burned. And so now the question is the risk, you can't get insurance, you'd have to go to Lloyd's of London. And so what you discover with wood construction is the big risk is during construction. And another one just burned down in Houston 2 or 3 weeks ago.
Do you know why they're burning?
Well, probably tradesmen, doing things, who knows. Have you ever watched them put down a roofing membrane with the gun?
I mean, I'm just wondering if it's something like, if it's a lead construction site, they're not allowed to smoke on site, I think. I don't know if that's correct or not. But it's like, are these things that are avoidable?
No.
Or is it just part of the...
Well, let's put it this way. We're early in the cycle of adopting wood, and so there's a whole bunch of things have to be thought through. No one really realized that during the construction phase, it is so susceptible to fire. Now, post and beam is probably okay, but this building is done in post and beam because, again, it's a recyclable, renewable material. It's a nice looking building. So they've got all the things here that we would like to do. They've got this is just their whole water management system. So they're collecting rainwater. You need to collect it. You need to store it. You need then to process it for potable water. and then you have to store the potable water, and then you've got domestic water use, which would be your gray water, and then you've got solar aquatic biofiltration, and then you've got water that would be used for irrigation. And so when you look at the complexity of the system, it's quite a, you know, it takes a lot of work and a lot of cost. And I'll go through these elements. So I'm just saying it's one thing to say we should collect and save and reuse water, but there's a lot of technical background to this. For example, just the use of plant materials for cleaning the water. But then you get the added feature that becomes your landscaping. You can see that, again, to meet the requirements on I think it was Leaf Platinum, they did use a wood laminate structure. We are seeing a lot more composites today, there's nothing new about this form of construction. Most of our old warehouses were built in this form. Solar energy, they've got a photovoltaic array, and they're using part of that for skylight glazing. Vacuum tube solar collector for preheating district water. If you've ever been to, you know, whether it's Turkey or the Middle East, you'll notice everyone's got a water heater on the roof, right? You know what I'm talking about, these little tanks that you see on people's roofs. I mean, solar heating for domestic water is common all over the world. It's been that way for hundreds of years. We're doing more with it now, and using glycol as an exchange to supplement your heating. And then photovoltaic solar shades. So, you know, in some parts of a building you want sunlight, in other parts you don't want it. And so again, it takes certain technology. Daylighting becomes very important, and what they've used here is a living shade wall, and I'll show you a few more details on that. And we are beginning to experiment more with how we use plant material on the face of buildings with the full sun. I live on a street that has very large trees. When we bought the house, my wife said the only requirement I have has to have a big tree in the front and 2 trees in the back for shade. And downtown Toronto has very good shade cover, and it makes a huge difference in the summertime. You know, and then after the war, the engineers in the new suburbs banned all these trees because the roots would get into the sewer system. So you definitely see, as you go through cities, you can see the old part of the city and the new part, usually just by the shade trees. And then you get into the energy exchange system, and you're trying to recapture heat. You're trying to use radiant systems, and I'll talk a little about radiant because that to me is sort of the frontier of some of these systems. Heat pumps using geo exchange. In other words, you're going vertically down with pipes, and you're using the constant temperature of the ground as a source of either heating or cooling. And so again, they've got 30 geo exchange wells that they've drilled down. If you own a big piece of property, you can actually run them horizontally. So you can see these systems. I mentioned before that building management systems are really important. And so you know, there's 2 things about sustainability at a building level. One is the enclosure, and the other are the systems. And so energy management features, you've got photovoltaic arrays, you've got ventilation penthouse. I'll show you a scheme that I'm working on where we're actually using a solar chimney. You've got living solar screen, you've got radiant slabs, etc. So these become very, very different. And the biggest problem I find in working in this area is getting consultants around the table. Number one, they're usually brought in too late. And number 2 is they just want to do what they did last time. So I don't know if you have access here to really good consultants who can deal with this, but there's very few firms in Canada that have been able to understand how, sitting at a table and figuring out solutions. This is the green wall, and it's rather interesting. Let me just see. Yeah, that's how it works. So it's actually, you can see it standing out from the building. It's like almost a.
Where's the green wall?
Pardon?
Can you point to the green wall? What I'm looking at, I don't see the green wall.
Okay, what you're seeing, this is the green wall.
That's it
And
right there.
these panels are angled, and they're made of like, chain link fencing?
We call it green screen down here.
What is it?
Green screen.
Green screen, okay. And so you then, now, I'm sure there's climates you can do this in and there's climates you can't do it in. But the idea is kind of neat in that in the summer you get, dense coverage. And then in different seasons, then in the fall, you begin to get more light in the winter the leaves fall off and you get more light in the building. So it's just looking at ways. Now, this is a high-rise building, but you could think of houses and this ability to use natural plant materials to enhance the performance of the building itself. So we're now beginning to see a merging of a lot of different ideas.
Have they been able to successfully have that withstand like year after year, or are they replanting it every year still?
No, you could do it. You could do it year after year. I don't know if you've ever seen houses here with. You must have ivy growing on houses
There's
here.
the embassy in Embassy of Ireland. There's one on Massachusetts Avenue that's had one for the last 6-7 years, and it looks like
It stays.
It's right across from the Naval Observatory.
Yes, that one.
So you have them here. Yeah. We don't have many examples. Yeah.
We also have a lot of dead ones.
Right?
We have some that work, but we also have a lot of dead
Yeah.
ones too.
See, our problem is that we have a few buildings where the brackets are sticking out, but then, quote, value engineering, they take out a piece. And they say, oh, that'll be for later, so. Again, courtyards with, planning for cleaning the air, etc. So landscaping is a big feature. And I only show you that because it's, and I'll come back and talk about a little bit of the management, but we are beginning to explore these sustainable buildings. This part, I'll move quickly through it, but I mentioned yesterday that most of the technology we use in cities today is pretty well 19th century. And most of it came out of the Industrial Revolution when we saw this merging of mechanical engineering, chemistry, etc. If you look at someone like Ian Morris, he'll point out that there was one thing that changed cities, and that was James Watt and his steam engine. I don't know if you know what Watt did, but it was a brilliant idea. It was very simple, and that is that the old steam engine was basically a pot. You boiled the water, and it went up and created steam, and then Watt added a condenser, and he revolutionized that technology. And so all of a sudden, this power of harnessing steam allowed us to move goods. It allowed us to move energy, to move into mass production, railways, et cetera, So it's one little invention really shaped the cities, all cities, for that matter, across the globe. And now the question is, are we going to see the same thing with the internet? I don't know. But the point is that basically most of our thinking today is still kind of 19th century models. And this basically led to manufacturing. It led to increasing in wealth for certain people. and other people not so much. It also led to these centralized supply-oriented utility companies. So you can see that the spin-off, because you had to have coal, you had to have transportation lines, etc. Of course, you had to have access to public goods such as water in the atmosphere, so you could blow your fumes without any real cost into the air. You could get water for your to make your steam, and so this led to I won't spend a lot of time on this, but you can see the extent to which we're still kind of wedded to the legacy of that period. So these silos, once a solution, are now part of the problem, and that's our dilemma, and it goes all the way even through our training and our thinking and our profession. We operate very much in a silo. I'm not going to dwell on this, but I always find it interesting to go back and look at infrastructure. Sometimes we think we're modern day by having wireless, and of course you discover that there was a lot of infrastructure goes way back in time, but a lot of it is fairly recent also. It wasn't that long ago. I mean, I always like to tell the story about electric street lights, because if you know, there's an island off Martha's Vineyard, Cape Cod, called Nantucket. And Nantucket was the whaling center of the world. And these boats went out for 3 years, roughly, and then they would come back. And one day, one of these boats came back, and there was no market, because they had figured out how to make gas from coal. And it showed how one technology sort of basically wiped out. If you go to Nantucket today, other than the museum, there's no vestige of it being the whaling center of the world. So there are consequences as we go through these inventions. And it wasn't that long ago that we developed sewer networks, and then of course Edison and his electric lighting system, which was kind of brilliant, because it wasn't what he developed was a system. One of the ones that fascinated me in the research was I didn't realize that we had pneumatic mail networks to move mail. Philadelphia had used compressed air through 6-inch pipes. 1897, New York City had 27 miles. And it remained operational until 1952. Paris had it up until 1983, and Prague is still using it. Now, you've probably seen them in the old department stores, right? Where they would put them in the container. But it's interesting to look, we forget just what infrastructure was about. Another one, this is just wired cities. Of course, Seoul, Korea is incredible, the linkage they have there today. New Songdo is into it. So you can see that the power of the British Empire really did go back to their ability to create infrastructure. So when they went to India, they built a train network. They were able to use steamships to bring goods from Bombay to ship into China. So I mean, most of the power of that empire was based on the steam, ability to harness steam. And it affected our country also. Now, I was interested in this whole question of technology and its impact on society and on cities, and I found this piece of research. Maybe you disagree with them also, I don't know.
No.
But this is Ian Moore at Stanford University. And what he points out is that the energy capture is the indice of cultural and socioeconomic growth. Because one of the things we know is that every person requires a certain amount of energy. And then that gets parlayed. And so energy capture is the foundation of social development. And so you can imagine if you don't, one of the things you have to, has anyone ever gone camping here where you've depended on cutting your own firewood and your own fire? Yeah. How many hours do you spend gathering the wood, cutting it, and lighting it, right? So you can imagine what it was like at a period in time where a large part of your day was spent just figuring out your food and your cooking. And of course, with the advent of technology, we discovered, in fact, that we would release more and more free time. And that's one of the great kind of attributes that we look at. And so what we do know is that we need about 2,000 kilocalories per adult per day. And that'll vary a little bit. And so the ability to capture energy is so important to our own. And that's what infrastructure is about. It's about capturing energy, utilizing energy in a way that allows us to lead a better quality of life. So what he's done is he's gone back and created this scale, and this shows you that, you know, for many, many decades, sort of there was no real social development, which, you know, when you think about it, could you imagine that your next generation is going to live the same as you did? Our expectation today is the next generation is going to live better. And if it's going to live better, what is it that it's going to make? So for a long period of time, until the steam engine, and then this social development score, he has quite a complex system of measuring this. And I'm not defending the research, but it's a very noted piece of work. But you can begin, and he also looks at the question of East and West. And so you begin to see the impact of one piece of technology on social development, and that's the Watt steam engine. And so there's no economic growth for 4 centuries prior to 1750, and then the Industrial Revolution comes in. And what he points out is the growth of productivity slowed after 1970. Huge drop-off. Now, if you remember, in the mid-70s, we started to see what we call the rust-outs, right? The Toledos, the Clevelands, the Buffaloes, the Detroits. And because why? Because the old industry, Boston, Philadelphia, all the old industries became very unproductive. They were still tied to old methods. And so what he points out is all that remained after 1970 were second-round improvements, such as developing short-haul regional jets and extending the original interstate highway with suburban ring roads and converting residential America from window air conditioning to central air conditioning. And, you know, there's a bit of truth in his words that we basically tampered at the edges and that there was no substantial improvement in productivity, and productivity began to decline. And so when we talk about energy capture, we're talking about it in basically 3 things: food, fuel, and raw material. We need food both for ourselves and for our animals. We need fuel for cooking, heating, cooling, and for making things. And we need raw material for building homes, making pots, or other things. So this is what he uses in his basic argument. He looks at Eastern and Western energy capture, and again you can see that things begin to shift here, but you can see that now what we get is a divergence between East and West. You have to remember that it wasn't that many centuries ago that India and China represented about 60% of world GDP, and then it dropped to 3%. And so when we look at Asia today, what we're beginning to realize is that they're probably coming back to what they were. And so this leads one to believe that the East never used the technology, or weren't allowed to use it, for example, to the same extent we did. It came in late. But it also corresponds to large cities. So this is his graph of social development in cities. And again, you see that east and west are similar, but around 2000, which isn't that long ago, we saw this huge shift. And it wasn't that many years ago, which, you know, it was, well, it's only now perhaps that we're beginning to use the word megacity. One of the 4 areas he looks at is war-making capacity. Because basically it's through war-making that some of the most rapid technology gets developed. So when you think of the 50s and 60s, a lot of it was based upon the technologies that were developed in a very short period, World War II, and then again you can sort of fast forward, and so again he uses this ability of war-making to talk about the impact it has on technology. So I only use that as it's only his example. You should read the report. But it doesn't, you can see all of a sudden we're you know, what has happened today is a very recent phenomenon. Yeah.
On page 152.
What's that?
On page 152, you ask a question. Was it one?
Oh, I know.
That something about mental. I think it was 151 and 152. I don't know whether that question was rhetorical. Are computers and other digital advances doing for the mental power what Stephen King and his descendants did for muscle power?
Yeah.
Is that a rhetorical question or an objective question?
Well, it's an objective question.
Okay, and what do you think the answer is?
I have no idea.
Well, yesterday, you remember in one of your presentations, we talked about intelligent city. That is the objective answer that the industry is saying yes. That the ICT, information, communication and technology, okay, is doing for human intelligence essentially what the steam engine does for. That in some sense now, it's not, I understand the Maurice research was social development, but there's a lot of research now in open science that is focusing on social innovation.
Well, you know what, I think I can frame the question.
Yes.
I think I would prefer more knowledgeable people in this area frame.
No, I'm just saying.
Debated it.
Yes.
But it does come up. I mean, some people think.
The objective answer is yes.
Because it does come back to my issue of energy capture.
No, you see, I guess
Because what I'm trying to point out is that so much of our social and economic development is based upon energy capture. And I don't quite know how to link IT technology to that issue.
Let me finish. So the energy capture is focusing on the material development of society. What the other literature is emphasizing is that it turns out that what is going to be catalytic about sustainability going forward is not material development, but social innovation. That doesn't involve energy capture. It requires intelligent decision making and social innovation.
Yeah, as I say, I don't feel that I'm.
No, so in the sense is that
But you know,
they are complementary.
Part of the thing I learned as an academic
Yes.
is I'm much better at framing the question than the answer.
Yes. I'm supporting you. I'm saying is that you focus on the energy capture because we're talking about social development. But what I'm saying is that I'll send you a few articles about the ones that is emphasizing that somehow the ICT connects to intelligence and social innovation, and they tie it to social media. And then in economics now, they call it about knowledge economy. I think you hear that, about knowledge workers. And the fact that now, for the first time in human history, we break through law of diminishing returns in economics. So
Send
all
me the articles.
But okay, so the issue of sustainability, okay, in terms of cities, is no longer a constraint on mega cities. that wants to switch the discussion along those
Well,
lines.
I think I could probably put 4 people in the room
Yes.
with 4 different opinions.
This is not an opinion, this is science now.
Okay, I could get 4 scientists that would
Yeah, this
disagree.
is no longer an opinion, this is science, open science, you know, so.
Science isn't all that objective.
Okay, no, then I don't, if you know, then I don't know what you're talking about.
Okay, well, you know, coming from a school that had some of the most brilliant scientists in the world, they were, you know, they were wrong, some of them. I can show you that they were wrong. I'll send you the article. Okay, so basically, I'm just going to talk about sort of emerging technologies in this field. I just put this up very quickly because you do begin to see how quickly we are moving in this history of technology and what's happening. I'm actually a part of an experiment right now on stem cell regeneration, and I'm in a double-blind test. I don't know what's going to happen for 6 or 8 months, but it's pretty interesting when you discover that we're actually looking at regrowing certain things in the body. Do the scientists know the consequence? No, not really, not yet. But you know, the whole area of stem cell regeneration is just one small example. And you know, if you looked at the most innovative industries, they do change by decade. Textile, railroads, chemicals, computers, internet. So there always seems to be a constant change. I would, you know, when I go back to my days at MIT, I mean, at one time it was the Lincoln Labs, getting a man to the moon, and by the time I left, it was neuroscience. They got out of defense work and they got into the neurosciences. So, you know, that gives an example of just where the science, the field of science is going. And when we talk about innovation, we're talking about products, we're talking about processes, we're also talking about management technology. So don't think it's about just making gadgets. And when we use the word product, we also include in that the word service. Just, you know, it's an all-encompassing. This one still interests me, and if you're in the real estate business, you know all about it, but Levitt was a logistics engineer in the Second World War. I think it might have been with the Navy, I'm not sure, but was fascinated, much like our associate in quality control. Who was the fellow who went to Japan and did quality control? Right.
We know who you mean.
Eh?
We know who you mean.
Yeah, I'll think of the name. But you know, Levitt came back, and this was really a process because we used to build homes one at a time, and we'd finish one and move to the next. And Levitt got the great idea was that unlike Henry Ford's assembly line, where you move the product and the workers are stationary, that he would keep the product stationary and the workers would move up. So one person did one kitchen cabinet, the next, etc. And so this was really revolutionary thinking. And so this is a good example of product technology, or process, because the form of construction was pretty well the same. But in those days, it was about, this house would have taken about 1,800 man hours of, I don't mean to sound chauvinist, I don't know what the other term other than man hours, but about 1,800 man hours, about 850 square feet. Today, if you were doing comparable, it would be probably less than 600, because what happened with the technology, it went on to create what we call value-added products. So the windows came with the glass in them, et cetera, et cetera. But you know, don't underestimate the importance of this housing production, because it basically revolutionized the suburbs. And of course, we get into this whole issue of push or pull. You know, are we driving the market, or are we assuming that the customers really don't know what they want until we see it? And if you you get into this, it's the innovator's dilemma. And we get into the issue of the value proposition. And that is that the customer is really buying benefits, they're not buying the gadget. And so one of the things that we do have to examine in all of this technology is can we explain what the benefits are of buying a solar panel? Because I know people that bought solar panels, and I go back and say, 3 years later, how's your solar panel? Oh, unhooked them, it's too much work. So what did you get them for? No. Well, we're committed to sustainability. So there's quite a bit of that goes on in this field. Yeah, the thing about Edison is that Edison replaced the kerosene light with a system. So he actually thought of how you produce it, how you distribute it, how you price it. And so the problem in solar is quite often in a lot of the technology today, we have people doing wind turbines, we have people doing geothermal, we have people doing other form, but we don't think of the system of distribution, the system of payment, etc. So we're very early on in this kind of transformation thinking on some of these technologies. So there's 4 independent or mutually reinforcing components what you have to think about. There's the enabling, there's the enabling technology itself. So the internal combustion engine gave rise to the automobile. But it was Henry Ford who then understood what it took to buy them. And as you know, one of the things Henry Ford did was he doubled the pay scale. Because he said, if my workers can't afford to buy cars, I'm not going to be doing very well. So he then, of course, he also thought about the roads, the gas stations, the financing. So he was a brilliant individual in taking an existing technology, the internal combustion engine, and putting that in a system. And going back to the push or pull, you probably heard the comment. If people just wanted to go faster, I would have made buggy whips. You need an innovative business model, and this is where we struggle at times. When you think that 93% of Google's income comes from advertising, and even when people look at Google, they're not clear on what that means, like who's paying for it. And so what we do find in some of this new technology is they have very sophisticated business models behind them. They know how they're going to create revenue. Those who don't build in a revenue part are going to struggle. You need a very robust adoption strategy, and you've got to have a high degree of ambiguity in your system, because the world is full of ambiguity, and so you've got to recognize that, which means that you've got to be able to test things and modify them quickly. Do you remember when Windows or Word came out, Microsoft Word version 1.0, and then 6 months later, version 2.0, 3.0. Oh, and by the way, these error messages, anytime you get an error message, send it to us. And so when you think of the development of Windows, it was all based on this ambiguity, and well, some things don't work, but we won't know if we don't get it out there. Now, so we were quite willing in the early stages of technology to accept very poor performance. Think back in the early days of the internet and all this stuff. I mean, it was just frustrating. But they could test it quickly, they could solve it rather inexpensively, and move on. And so you have to have a value proposition that promotes a willingness to overlook initial shortcomings. You will not get it perfect. In India, we have a phrase which is good enough. And that is, you know, it doesn't have to be perfect. North Americans kind of assume that a product they're being oversold if it isn't perfect.
Well, I'd say in India, that mentality is part of why the built environment is so fragile.
Yeah,
Like, it's just gonna crumble.
that's right.
Because everybody says, like, okay, it'll go from the ground up, the whole damn building's gonna fall down.
Yeah, and it does sometimes.
Yeah.
Yeah, it's good enough.
crazy.
Yeah, I know. It has good qualities too, though. Because the building should have fallen down. And then you need good government policy. You know, a lot of regulation prohibits things that we would like to do. I'll just quickly touch on the green technology. This phrase covers a group of companies that are so-called green providers. And there is an index called the Green Tech Index. So it's interesting. The green technologies are those that harness power or seek to reduce adverse human impact. So they include solar, wind, geothermal power, biofuels, smart power grids. So we are beginning to see the rise, but if you remember the graph I showed you before, it's a kind of a rocky start. I mean, we were heavily into solar panels. They haven't been that successful. We've been heavily into electric cars. They haven't been that successful. The good news in electric cars is I think now that we may have turned the corner. So if you look at the electric car, and I think what I'll do, I'm going to show you a video. Does anyone know about Shea Agassi's work? He was the head CEO of a very large firm called SAS, the software firm, and decided that he would build an electric car. He would sell everything, and he had this passion that he had to help mankind, and he would develop an electric car. And he developed it in Israel, and he wanted to make electric transport easy, reliable, and affordable. And he had some of the same thinking of Henry Ford. So if you look at these four things I talked about, market adoption, technology, the business model, policy, he decided that he would go to Israel because it was a country that was very small, the market was easy to define, and it was a country that was not heavily dependent on, they wanted to minimize their dependency on oil, and they're also very strong in promoting technology. I mean, the number of technology firms that come out of Israel is quite startling. I don't know if you're aware of that, but and the Technion in Israel is a very well-known university. Technology, his idea was quite interesting. He said, why don't, like airlines, why don't we sell the car and rent the battery? Because the battery was the big price problem. I don't know if you know about the airline industry, but the motors are rented on an hourly basis. And there's real-time maintenance and servicing. So Rolls-Royce is actually watching all those motors and determining, so the airline doesn't, they don't own the motor, someone else owns the body of the aircraft, etc. It's quite an interesting business model, because you often wonder, who the hell's paying for these expensive airplanes? So his idea was that, that you would basically pull in, they would pull out the battery and replace it. And you would pay on a usage charge. His business model was that his company would own the battery, and it would sell you miles, and it would make its profit the difference between the cost per mile for gas and the lower cost for electricity. So you would be paying essentially him the gas costs, and he would be then making his profit on the difference. Policy was that Israel agreed to drop the import tax to 10%, while rising, putting it up to 72% for gas power. If you go to Israel today, you see the tax on a car. We were going back on this issue of pricing. Israel's a good example of that, where I think the total tax on a new car, all of them are close to 90%. Now, people have cars. So I'm going to show this, and then we can break for lunch. It's kind of interesting. Uh-oh. We have to hear this one. Any idea how we get sound?
Where's Lynn? I can't see it.
It's not
Hey?
there.
No, it's
Put it on here.
Oh, it's on.
Where's Lynn when you need him?
Yeah. John? John.
Come on, John, you can.
Do we have a guy here?
Yeah, John used the computer before.
There.
Let me see if there's anything back here that looks like it's not.
Oh, it's
I
like
can
on the
back.
PC.
Awesome. Ouch.
Do you think it's up on the on the thing?
Wait,
Maybe.
that's
It's like the other classrooms. Yeah. It's just like that right there.
It looks like it's giving sound.
Magic button, right?
Oh, there's
Come on,
classrooms. There's
Jen.
one that says sound.
You could read lips for us.
So your friend doesn't think much of TED, eh? The one that invented it?
Oh, no, Ricky Werman invented TED. It stands for Technology, Education, and Design.
Right.
He then, it was a non-profit, he actually sold it, but he doesn't like it today because he says that it's a crass commercial venture with no quality control. Anyone can post something on
Oh, I see.
it. That, he doesn't like that it's become a big, you know, the whole idea was that it would be an exchange of ideas at a very high level.
John, what's that gray remote?
What?
This is for the projector.
Well, we may have to move on and do this after lunch.
I think Dan's trying to go have someone.
Yeah.
Yeah, so I
thought there might be a sound switching thingy on the
Yeah, there's
podium,
the button.
but there's.
Okay, I'll show you.
These are all the.
There's a high level of ambiguity in our system.
Yeah.
Yeah, just, cut some splices.
So we'll skip this, okay. I'll just, we'll get it playing later because he's so passionate. And when you hear this presentation, it was done about 4 or 5 years ago, you are 100% convinced that this is going to work. It's a brilliant idea. He's so brilliant. He raised $500 million to back it up. And of course, you fast forward, and the story's not quite good. The business model didn't work, and Israeli customers don't seem to be taking to the business plan itself, and there was some failure in marketing. And one of the things that the critics are saying that he didn't figure out how to integrate it into the current system, particularly the rental system. And so when people heard that they were going to rent the battery, the rental car companies went out of their way to kind of try and make sure he could survive in their market. So it's unfortunate. It was a brilliant idea, but the other problem is that these battery stations ended up costing $500,000 a pop. Because you had to have, you had to charge it, and then you had this automatic machine, literally, that you drove in and it pulled the old battery out and changed it in 30 seconds. So that became, so part of the problem with electric cars is just like Henry Ford understood that you had to have gas stations, you had to have charging stations. So his business model, unfortunately, failed. It burned about $1 billion. And it filed for bankruptcy in May 2013. Two major limitations kept electric cars from going mainstream, and both center on the battery. For one, charging stations are limited. The car produced by Better Place had a range of about 100 to 160 miles. This is a big issue. This is where Tesla's good. Tesla's good for 250 miles. But there's that notion that even though I'm only going 15, 20 miles a day, what happens if my battery goes dead? And it just seemed that 100 to 160 was too short. And another problem is cost. The battery tended to be very expensive, the whole battery and the system itself. So it turned out that Agassi's solution, very elegant on paper, but it didn't quite work in the real world. And the overhead was very substantial. And the fatal drawback, even when the station had been built, customers remained unconvinced. The company could only attract 750 drivers. Very small number. But it was when he presented as a TED Talk, and I first pulled it up, I thought, this guy has got it. So, you keep trying. And this is a great example. I think it will succeed. It is now the world's leading electric car maker. Have you seen a Tesla? Mm-hmm. Everyone's seen one? The Model S has tracked consumer demand. In other words, they seem to be able to capture a slice of that market. But the big thing, it can do about 208 to 265 miles. It doesn't take an expensive station. And so their sales have gone up by about 55%, and I think in the first quarter this year they're delivering 6,400. While Better Place solution was this battery interchange, then Tesla has not gambled on that kind of system. Now, what Tesla has understood is that the biggest constraint on them expanding is the battery. Battery is very expensive, it's heavy, so they're investing $1 billion now to develop a new battery. And he's hoping that that will move into the next level. So these are both 100% electric. I was in Atlanta just a few weeks ago, and my daughter said, I'm buying a Nissan Leaf. I said, that's an electric car. She said, yeah. She said, drive the kids to school. I figure I'm only doing 10 kilometers or 10 miles. And quite a few of my friends are buying the Nissan Leaf for that very short commute. So I was surprised to hear that it was taking hold. So Norway, last month set a new single model sales record, and the Tesla is the best-selling car in Norway today, replaced the Volkswagen Golf and the Nissan Leaf. That's startling. And this is in a cold country. So sales of Model S beat out a long-standing sales record, dates back to 1986, when the Ford Sierra was topped off. It's basically trounced the sale of Volkswagen Golf, formerly Norway's car, and so kind of interesting. Now, when you ask or read the car critics why Tesla's selling, they said it's not because it's an electric car, because it's a good car. And a customer still wants a good car. And it's not just good, it's better. It's quiet, it's got great pickup. And so and it's not cheap. I don't know what they are here. They've got to be,
60, 70.
how much?
They start at 60, 70.
Yeah, which means 80. Now, it's not a cheap car, so it's competing with, let's say, Audi, Mercedes. It's in,
What I heard just last week is that by 2017, they want to have one priced for that $20,000 to $30,000.
yeah, as soon as they get this battery problem solved, because they can't move down because of the cost of the battery. So, but I don't know if I mentioned yesterday, but Tesla is now, as a company, is valued at about 60% of the market cap of GM, which is surprising. I didn't even know about this car probably 12 months ago. China had just miserable. China launched a huge government program to promote electric cars, and you can see this is an index done by McKinsey, and it shows 2010 to 2012, and Japan has not moved, and you can see that the United States has. So we are seeing some upward movement, but the electric car in China has, and I don't know why, but it's been a miserable failure. And so certainly I would say that we're beginning now to see evidence that, look at United Kingdom on this index up here. Italy is going up, Denmark is going up, but Japan has really jumped. They were down here, so the electric car is really, but it's a bit like the PC, where we used to get battery life of maybe 4 hours, and today we can probably get 8 to 10 hours. So once you solve the battery problem. So I'm very hopeful about this. So just to highlight that, I'll use this as the last, is this shows you the interaction of battery and fuel costs, and this will determine the size of the market. So this is fuel price. It goes back to your issue of pricing, right? Here's fuel price. So they're very competitive when you're up around $6. PHEVs are the hybrids. Plug-in hybrid. Here you get electric vehicle here, and then ICE vehicles are. God, I thought I listed all these bottom, all the short form, but I always forget these.
Internal combustion engine.
What's that?
Internal combustion engine.
I'm sorry,
It's
yeah.
ICE.
So what you can see how sensitive this market will be to the pricing. I mean, our gasoline, we pay, the cheapest grade, we pay $1.35 a liter. So what's that roughly comparable to? $5 a gallon? 6? Yeah. And we think it's cheap. If you go to Europe, and one of the things that's very surprising is how long it's taken diesels. You go to Europe, almost everything's diesel. So I have a friend who's head of sales for Porsche, and I said, why don't you have more diesels? And he said, can't get them in the U.S. market. He said, there's such a lobby by the American manufacturers using California emission control. And he said if you take trucks, they have to, diesel trucks have to, this thing every 10,000 miles, they have to, the catalytic converter has to burn, or I don't know what it is. But he said trying to get diesels in the US market, he said it just, you know, the lobby groups have really prevented it. They're making some headway, but we used to have diesels back in the 70s, then they disappeared. And now they're starting to come back. I think Volkswagen's has brought them in on almost every model. Because the question with the battery car, it really is whether the internal combustion engine with the new regs will in fact knock it out of the market. Because when I go back to my original slide, how inefficient the ICE model is, and we're finding that efficiency can be radically shifted. And I think with the new, is it 2020, you have to have a 50% reduction in fuel consumption in the United States. And already the Ford 150 is moving to all aluminum construction. Because knocking 1,500 pounds off alone makes a huge difference. So the car manufacturers, so that's the dilemma in this model is that I wouldn't, I don't think they're prepared to throw in the towel on that one. I think that we can take a break, and during that I'll try and get the, yeah, that would go into building technology. Okay?
Good. So,
I mean, I know it covers a lot, but it's good stuff.
good. Our plan is to have lunch.
Yeah.
All right, but that plan is hinged around Lynn Mao getting us lunch. And,
Is he MIA?
Sarah. Lynn, can you hear me? So we'll see what
Missing in
that.
action, huh?
I have a feeling we haven't turned on the speaker system. Yeah. Yeah, just a second.
Miss Kim. What's up? How are you? Good, how are you? Are you going outside? I think so.
When I first graduated from
Four
college,
walls, like
I
lunch.
was,
Food is so cool.
contractors
I
with
do.
Department of
They'll remember you.
Yeah.
So we came over in the fall.
All right.
We came over in the fall and like walked outside for lunch or something and came back in and they were like, where's your ID? And like made me sign back in.
And
I was like, okay. Like, there are
Do
seven.
you have your computer here? A little laptop that I can borrow?
I do.
Yes,
But I
please.
think a
I
lot
was
of
actually in your class for one time, but it had
as
to
you
drop
said, it
because
could
it was so
go
busy.
technology.
Which
Because
is
just,
No, here.
5 years ago, when I was there,
I mean, laptop.
everybody was using nickel cable.
Yeah, now it's.
And the energy density on those is terrible. They're
That was Northern
really,
They're kind of nasty.
Macro.
Oh,
yeah, they're
macro.
really
But,
bad.
I'm just.
And they weren't able to get,
Oh, okay.
the,
Sorry about that.
No, it's good, it's a good thing.
with the lithium ion batteries.
You can just fold it and stick it back there when you're done.
Okay.
Oh, if you need internet,
Yeah,
Yeah.
yeah, that's what I did.
So I think they're finally overcoming a lot of the limitations.
Well, I think that, well, you know, Tesla's announced $1 billion, and then another competitor's come into the market. They're gonna put $1 billion in, so we've been kind of waiting for that frontier of battery technology.
And the Department of Energy was backing a lot of those battery companies. Like the company, I think it was Southern Johnson Controls joint venturing with SAP, or it was a Korean company that built all the batteries for the Volt. The Volt's almost entirely funded by the DOE.
Is it?
Yeah. But now that's become a tremendous flop because it's ugly.
Yeah, the Leaf seems to be a bit better than this Leaf.
Yeah.
Well, it's not a pretty car, but it's not an ugly car.
I think that Tesla made, I think the best move that they made is they made it sexy.
Oh,
You know, they must have hired somebody from Peanut Grana or
Yeah.
something.
Well, you know, it goes back to